Namaste guys. In this video, we are going to learn how to do a simple CAD simulation in Solidworks. After that, while doing the simulation, we will also learn how to analyze the result, generate a report, all in this video. So let's see how to start. So first click on here, click on new and select the part. We are going to do a part simulation. Click OK. So this is my view. Now let's change the background to plain white. After that, first thing that I need is I need to create a part for the simulation. So click on sketch, select the plane as per your requirement. In my case, front plane that I prefer. Now I will draw a shape of T. You can draw any shape as per your requirement. A advice for those who are beginners, try to make sure that your sketch is fully defined. As you can see that my sketch color is blue, it means it is underdefined. As you can see right now, underdefined means that the dimensions of all the sketches, line or diameter radius, if it is used, it is not correctly defined or it is undefined. So let's define it. So I will select this line and give it a dimension as per my requirement. Let's say 100. Let's say this one is 25. And from here to here it will be 50. Now let's give dimension to 25 and this one will be 75. I'm just making it rough, so don't expect that I'm making it correct everything. Press escape key. Now by pressing Ctrl and select this line, select the make midpoint. Okay, press Ctrl Z, select this and go to the smart dimension. Just make the distance to 0 and press escape key. As you can see, it can move up and down. I don't want it. So what I will do, I will go to the smart dimension, select this and this one, make it 12.5. Or what you can do is type 25 divided by 2 and enter. As you can see that my sketch is fully black and you can also see it is returned fully defined. So this is the best practice that you need to follow. So click on features, extrude, select this face and this face. Click on mid plane. Basically it will going to extrude on both sides. Enter the thickness as per your requirement. In my case 25 mm. Now I think it's fine for me. After that, what I'm going to do is I'm going to do simulation. Go to SolidWorks add-in, click on SolidWorks simulation. Wait for a minute because a tab will appear for the simulation. As you can see, simulation tab is appear. Now click on here, click on new study. You can see different kind of studies are showing here. So what I'm going to do is I'm going to do static simulation. I'm not going to check 2D simplification. We will cover this topics later onwards some other time. So click on static, click OK. So what does static means? Static load is applied and the load is static. For example, you have a table and you have put a glass. So the glass put a static load on that table. So this is what it means, static loads, a load that is not moving. Now, before we do the simulation, we need to define something. As you can see, these are the part is defined. Uh, Basically, part is defined, but what is material? Basically, on which material we are going to do this simulation. So I will select the apply material. So you can choose the material as per your requirement. In my case, I am choosing alloy steel, but you can use it anything as per your requirement. You can also see the material properties as you can see here, and you can add the data if you have appearance, change color. It is up to your requirements. As you can see, I'm using SI units, but for those for England or America, you can choose IPS as per your requirements. So I am choosing alloy steel and click on apply and click on close. You can see that it is now written part 2 alloy steel. Great. The second one is connections. So connection is basically used when you have more than one part or there is some kind of connections in between them. But as you can see that I only have a single part. There is no another part or there is no something called connections here. So I don't need to do anything here. Next thing is fixtures. So what does fixtures, when I say fixtures, what comes in your mind? Fixture basically means to fix something. So what I'm going to do is, let's go to, you can right click here and apply the fixtures from here, or you can simply click here and apply the fixtures here. They both have the same options. If you click on advanced fixtures, you can see everything. So I will right click here, click on fix geometry. Now it is asking what you want to fix. Let's say I select this face. So this face will going to be fixed. As you can see right now here, the green face is fixed. So here you can see other part can be moved. So this is what it means, fixed geometry. If I click on roller slider, you can see it can roll slide along this face. Another is hinge joint. You can see, because this simple CAD simulation, I'm going to use fixed geometry. So I will select this face here and I will say, hey, that this part is fixed. So let's try to visualize it. So I made a simple dummy version here. So, so what fixed part basically means is that this face will going to remain fixed. This one, and but other one can be moved like this, up and down, left and right, etc. So this is what it means, fixed geometry, that this face is not going to move. Now after that, to do the simulation I also need to apply some load, because that's basically what I want to do. So there are plenty of loads. If I right click on it, you can see pressure, centrifugal gravity, etc. So I'm going to apply a simple force. So what I will do, I will go this time here. Okay, you can also apply load from here, but let's do from this time here. So I will click on force. Now it is asking me to select a face. So I select this face, and it is asking me what is the force, how much force is acting. Let's say 200 Newton. You can apply or change the force as per your requirements. If I click on selected directions, I need to select the edge. So you can see that it selects the direction. If I click on reverse, the force will go upwards. You can visualize it properly. But let's use normal for the sake of simplicity. Now click OK. Now I have applied the load and fixed my geometry. Now what I can do is I can run this simulation. As you can notice that simulation is run. Now here are some other properties, something called create mesh. So what does a mesh means? So basically, higher the mesh, higher will be your result mesh. Higher the mesh quality, better will be the results. Lower the mesh quality, lower will be the results. But a drawback. Let's say you increase the mesh quality. Now it will take more time to do that simulation. But if the mesh quality is low, it will take less time. So it depends upon the part, or the how important that part is, or cost. Higher the value or importance of that part is, then you will choose high mesh quality, so that you can get better results and judge what you need to do about that part, or where you need to modify it. Once you are satisfied with the mesh quality, you can see I get the cost fine mesh. And let's say create mesh. Now let's reduce it, click OK, and you can see it's bigger one. So smaller the size, better will be the result. So I will go here, click on this one. So you can see it's small one. Now I will click on run the study. Once you run the study, you will get better result, but it has a drawback. It will take a time. Now after the simulation, I got the result, and you can see that we can clearly see how much stress is there. If I right click on displacement, click on show, you can see that how much is the displacement. A question comes to your mind. Here the value is 0.001, but the displacement looks here that it's very big. Is there some kind of issue or some scam going on? So let me tell you what actually happening in reality. So the 0.01 or even the 0.2, 0.02, 0.00256, it's very small value. I can't see if there is a deflection in front of my eyes. So what SolidWorks do is it basically make it 10,000 times more than the actual so that we can visualize it. So let me show you. Right click on edit definition. You can see automatically that this is the scale factor. So if the value is very small, it is multiplying with this one so that we can visualize where is the displacement. It's a very beneficial for you. You can also define custom or true scale, but true scale will make it look like there is no deflection. Let's click OK. Notice deflection is gone. So I go to edit definition, click on automatic because I like the automatic one. Now let's try to do the animation. So click on animate. As you can see from the animation, we can visualize it. Right click, show. Now it is showing me the strain. So right click, show. It is showing me the stress. As you can observe that here at the corner, stress is maximum. So what I can do to reduce the stress here? Any guess? Think about it. So I will give you some tips. Add a fillet and rerun the simulation. So this is the homework for you. I want to see what you observe and what is the result. For those going to ask what should be the fillet value, try your own. Do the mistakes. That's what is engineering about. The more you do the mistake, the more you learn. So be free to do whatever thinking or uh, comes to your minds. Now another is section clipping or ISO clipping. Let's say I choose section clipping. So in section clipping, what I can do is I can see from the inside of the part that what is the stress inside of it. So let's say your part contains hollow cavity. At that time, this section clipping will be very beneficial for you. But there's no hollow part inside or cavity here, so it's not much better for me. Next one is ISO clipping. So ISO clipping basically tells what is the value range that you want to see the stresses. As you can see, it is easier for me to visualize where is the high stress, where is the low stress. Very beneficial. Let's close it. And mesh sectioning, others you can animate and save them. One more thing that you can do is click on report, and you can add all the details, for example your parameter, load, mesh, etc. Okay, you can give the name, like let's say the designer is CAD knowledge. If your company have logo, address, etc., you can put it and you can save the report the path. Okay, if I click on publish, what will happen, it will create a report for me. It will be a very beneficial for me because it saves me a lot of time to do the report task. For example, you have to submit your college assignment and they said, hey, create the report. So Solidworks has an inbuilt feature, so it saves me a lot of time. Trust me, a lot of time. As you can see that it is currently creating a report, and it's very beneficial for me. And some other questions, for example there are other things like connections, etc. These things we will discuss about in future onwards. And one more thing that you can see that my simulation report is done. You can see the date, channel name, etc. And it is made by the SolidWorks, so it's much better. And you can see the load, material properties, yield strength, etc. So it's quite a good thing because it saves a lot of time to make your reports. You can see the mesh quality as well, reactions, free body surfaces, etc. Other parameters. So I hope you guys learned something from this video. If you have any kind of doubt and queries, feel free to ask. Thanks for watching and have a great day. Namaste.